1, 2. Can you hear me? 1, 2. Oh. Well, hello, and welcome to a special Dev Club, kindly hosted by Wise. And well, it's been a while. It's actually been like around 2 years since the last one. And thank you for making it here, despite the nice weather and summer being definitely like an off season for us. You're amazing for making it here. Thank you so much. And so before we crack on, I want to also give a special thanks to our supporters. Wise, of course, being such a great host and letting us in the building tonight. And there's also some more people and companies who support DevClub, which is really awesome. And back to today's agenda, we have 2 talks. If we can have the agenda slide back. Thank you. We have 2 talks. One is on orchestration of data pipelines by Otto, Wise's very own data scientist, and everything ETL and Apache Spark and all that. And then also another one on Flaky tests. This is more to dedicated to software engineers writing tests and at times being unable to make sense of them and why they're failing and what one can do about them. So yeah, let's have some fun. And also in between there will be some pizzas and some soft drinks after the first one. So enough of myself. I would like to invite Otto on stage.
Thank you. 1, 2, testing. Can you hear me? Yep. All right. Perfect. Can I have the slides, please? Yep, I am sharing. Right there. So, thank you for coming. I am a data scientist here at Wise. Before we start, I want to address the convoluted title to avoid the word big data. Now you see that I decided to just go on and put it there, right? Because we try to avoid this word. It's not so nice. Sometimes it is nice to put on your CV, but what it really is big data, right? So today we have a talk on pipelines, data pipelines. And this is supposed to be something that caters a little bit to beginners. So I'll go very quickly through Airflow and what you should do and you should avoid in Airflow. And after that, I'll talk a little bit about Spark 2. Let's see how time goes. I have planned that we should have 30 minutes for a demo, maybe a little bit more. So a little bit about myself. Whoa, that was loud. 1 second. Better? Yep, okay. So I am a data scientist here in FinCrime, and I am a computer scientist by training. In my free time, I enjoy doing things like sailing, practicing jiu-jitsu, although nowadays I can hardly fit in my gi. Yes, I have gained a little bit of weight, but my girlfriend is on that, so losing that. And also playing CSGO, a little bit of a nerd, but yep. And coffee, making coffee, drinking coffee all the time. Maybe I have had a little bit too much today, so bear with me. Right, before we get into the demo itself, I'll talk a little. Wow, the sound is really varying, right? Do you think it's best if I get the mic? Or is the volume okay? Yeah, because to me it's varying a lot, but okay, all right. Anyways, we'll talk a little bit about machine learning in FinCrime. Yeah, it is. All right. All right. So coming back, talk a little bit about machine learning in FinCrime at Wise. Again, we have many squads and machine learning in most of them or all of them. I'll focus on the use case in FinCrime when we talk about fraud, anti-money laundering, scams, and other things. Talk a little bit about the motivation of this talk too. And then we go through the demo. In the demo, I'll talk a little bit about orchestration and computation. You can see here that I crossed out DBT. I was going to talk about it, but we're still playing with it, so I don't feel confident talking to people who might know much more than I do. And then we have the closing talk. Just before we start, let's see here. Do we have people here who work actively with Airflow? Can you raise your hand, please? People who work with data pipelines. Ooh, okay. Software engineers that know how to use Scala. Right. People looking for jobs. All right. So why are we here at Wise? Wise is a global company, technology, right? And we want. Oh, sorry. Coming back. Right. So we want to build a world where people can have money without borders, right? What does it mean? It means instant, convenient, transparent, and eventually free. Wise has launched in 2011, and since then we have been working hard to become operational and profitable. We have been profitable for 5 years now, and today we help over 13 million people transfer money across the world and businesses too. And monthly we have an average of 7 billion euros transacted in our platform. That means 1 billion euros saved in fees every year. Right. Now, where does FinCrime come in this? FinCrime has a direct impact in some of the pillars, right? So we have instant, convenient, transparent, and eventually free. How do we impact the part of instant? Risk assessments. Our risk assessments have to run fast so that we can have instant transfers. Right now, we are at a rate of 49% of transfers in our platform are already instant. What does instant mean? Well, 20 seconds, right? But that's our definition of instant because we're sending money across borders. Then convenient. How do we impact convenience? The precision that we have to detect fraud and non-fraud. Is the audio still okay? Yep, all right. So the precision at which we can detect fraud and non-fraud directly impacts on the user experience of our customers, right? You do not want to be blocked or have your money blocked when you're just a good customer that has a long history with us. And eventually free. Right. Our ability to detect fraud, scams, our ability to comply with regulators, to comply with anti-money laundering regulations, all of these impact our bottom line product cost for our customers. Now, you may say that, hey, the solution to solve all your problems since you're scaling is just hire more people, right? And well, that is the case, one possible solution, but then we would never get to eventually free. That's our objective. So in order to be eventually free, we have to find another way. And luckily, we have seen in FinCrime and other squads too, that machine learning can help us achieve some of the benefits and maybe even scale more without raising the costs. It means more scalability, less complexity when managing static rules, discovery of different behaviors that humans cannot see, and evolution of new trends in our data. What is machine learning? Very brief, machine learning means features, models, and labels, right? Features are data points that you can use to capture a given behavior. Models are, people have very convoluted explanations of what they are, but simplifying, models are software that can learn rules. So instead of doing a bunch of if and else in your code, you give the model data, features, that capture a given behavior, and let it give back to you rules. That's the idea. And labels are decisions from humans that help a model assess whether their rules, the rules that they created, are good or not. Right, models need data. How do we get data? We have production systems, right? And these production systems, they compute features real time. From there, we can get data to databases, and we have our analytics platform replicate this data to Snowflake. Right now, we use Snowflake. Are you aware of it? somewhat of a big company, right? So yes, we do use them very, very often. And after that, we get to the part of this talk, which is extracting data from Snowflake, the pipelines, right? What do we use in our pipelines? Well, this slide's misplaced. Sorry about that. I was going to say that all problems are solved, right? Nobody needs to worry anymore. We can just go home because everything is beautiful. Yeah, we have things that we need to improve. So what did we need to improve? Airflow is the orchestration tool that we have. This tool is, well, we love to hate Airflow, but the problem is not with the tool, is with the way you use it, right? So lack of modularization caused us a very, very hard time, caused us to have a very hard time testing code. It was very hard for us to test, and that caused a bunch of one-line pull requests. Who doesn't love it, right? In the end, you can just say, hey, look, I had 2,000 PRs in 2 months. Wow, you must be a genius, right? Yeah, not so much. Spark, we lack optimization of some of our scripts. That means slow compute and a lot of out-of-memory issues. And the queries, we still have some problem with that. We have been working actively on lack of incremental logic, right? What happens is that you go to your data grip, Snowflake, you create a query there, you limit by 5, and after that you just take the 5 out and put it in some pipeline. Now expect it to run, right? It doesn't, well, sometimes it does run, but you see that it takes a very long time to do it. How was the pipeline before? Well, you can see here in the picture that we have a bunch of reds, a bunch of yellows, some things that never actually ran, and our computation time was in around 6 hours and a half every day in the morning. That was the time that it took for us to extract data. It is a lot of data, okay? You can ask questions, I'll talk a little bit about it, but right now we're somewhere around 700 gigs for one of our datasets. So how much data is big data?
Do you want questions as you present, or do you want people to batch their questions towards the end of this slide?
Let's do it now.
Yep. Okay, thank you. So yeah, whoever has questions, then feel free to raise your hand. Thanks.
All right, no questions about big data. Nice. All right. So yes, we do have big data. If nobody complains, let's call it. How is the pipeline now? 1.5 hours to compute, 1 hour and a half. So from 6 hours and a half to less than 1 hour and 30 minutes every day. Is this perfect? No, we still have a lot of opportunity for improvements, and we'll talk a little bit about this after the demo, but it's already much better, much more reliable. You can say that there is some pink there. The pink was a date that we paused the pipeline, and then when we re-enable it, we didn't have to compute these things because now we do incremental processing. So look, we don't need to do it anymore. How does extraction work? Well, like I mentioned, we have Airflow, Spark, and this technology that some people are aware, it's called Delta from Databricks. Have you ever heard of it? It's actually open source. Just one person. Nice. Data engineer? Yeah? All right, let's talk afterwards. Anyways, so Airflow to trigger jobs, and then Spark to compute, and Delta to version data. All of these tools can do much more than that, but that's the baseline use that we have for the new pipeline. Demo. Before we go to the demo, do you have any questions? I have a hard time figuring out how I'm going to do the demo and hold the mic, but let's see. So let me open up here. Okay. Let's actually run Airflow. All right, it's starting. So, wait. Right, this is the EU. Unable to connect. Technical problems, 1 second. Okay, Airflow is ready for us to open it. Let's go back, open the UI. Ooh, okay, that was unexpected. Just 1 second. Yes, this is not a production system. I didn't do this, Airflow does this, right? But that's just development. So yes, don't shoot the messenger. Oh, wow. Okay. So we're going to have a live session of debugging passwords instead. Yes, let's go with admin. Let's go. Right. Nobody even remembers it. It's not being recorded, right? Okay, this is not that good because we have examples here. So right there, when you start Airflow, now this has become a little Airflow tutorial, right? So you come here, you go to examples, and you take the examples out. Oh yes, they are out. So let's go back to the terminal. Let's see what's up. Let me open a different one. Let me define. Good thing we have a bunch of IT support here, right? Yeah. Remember, I'm just a data scientist. You guys are the engineers in IT. Password. Yep. It's not the correct one. Oh, right. Go figure. Anyways, so you can see that I already have a DAG here. A DAG is basically a pipeline. I'm not going to get too much into the details. So we have the first example. You can see that I have already run something here. I didn't want to run this live because it takes a long time to compute. If you look at it, 21 minutes, right? But let's look at the code, what this first one is doing, because this is the most traditional way that people start creating pipelines. You have Snowflake, right? Snowflake can do all the processing for you. So you go to your code and then you do all your imports, right? The most important here is Snowflake operator. You're going to create a little DAG for yourself, which you can just say that is the same thing as a pipeline. Right here in your pipeline definition, you're going to create a task. Your task is a Snowflake operator task. It's a query, right? So who here is familiar with queries? Do you work with queries every day? A couple of people? Yeah, nice. Yep. All right. So this is a simple query. It inserts data into a new table, creates or replaces the table, and inserts data, right? You can see here that I use some what's called templates to hide data that you shouldn't see, right? Information that you shouldn't see about our databases. And then here you have some control for date. This is information that you get from the pipeline. So you can actually access these macros so that you can control the operation of your pipeline. This is a terrible, terrible DAG. This is a terrible, terrible query because it's computing the same thing over and over again. The only difference between one day and the next day is the new data, but you don't care about that. You recompute everything, right? What is this doing? Can anybody tell me? It's selecting the user ID and the max transfer date. That's it. As simple as that, right? And you can see that it takes 21 minutes to run. So we must have a lot of data behind it. And if you go to Snowflake, which I won't do because we have a lot of sensitive information, but we have huge machines and we're paying a huge amount of money to run dumb things like this. And when we first looked at the pipeline, we realized that there were a bunch of this kind of queries happening every day. Remember, 6 hours and a half to compute. So how can we improve this? Suggestions? What do you mean by that? So think about this computation, max date, right? So every day we have new transfers and we have batch processing. So we have the replication happening overnight to Snowflake, right? The difference between one day and the other day totally depends on the date. So if you have a query that depends on date, you're doing it wrong if you're recomputing everything every day for this kind of computation, right? Because you know that yesterday the max date is yesterday, maximum. Some users don't transact, so then you have stale dates. But the maximum date that you can have is yesterday. Now that you are running the new day, the maximum date that you can have is today. So why not break this operation into incremental computation? Let's do that. So I have my AI assistant writing code for me here. As you can see, it's there, right? It's a little bit more complicated, isn't it? Because now instead of having just an insert operation, you have a merge operation, right? And this merge operation looks at your table that you have already created and the new chunk of data that is coming in. Where do you define this chunk of data? Between yesterday, so you add the date -1, and today. As simple as that. Now you have a query that is going to run in seconds, hopefully. So let's save it here. Not going to go into much more detail than this in Airflow, right? I'm going to jump the next part to testing. So decoupling the two things, computation and orchestration. But let's just see if this runs. Damn, didn't even have time to show it actually getting queued and running. It has already done, right? So it's already done. Let's clear it, come here again, say now pretend that it didn't run. Let's run again. So highlight green means that it is active. It's going to go to authentication. And then we come back here. It's going to show that it is actually running. If we go to the Snowflake UI, you would see the query submitted there and in the stage running. And hopefully it's not queued in the database, because that's what can happen when you have a bunch of people using the same warehouse. Let me take a look. Yep, so it's done. How long did it take? Let's see. 44 seconds. It's okay, right? Compared to 21 minutes. So right there, simple little trick that you can do, just changing the way that you think about your data, you can now get a bunch of boost in performance, right? Reduce a lot of your computation and the expenditure that you have to. Right, let's go to the next topic. Any questions here? That's a beautiful question. We're going to talk about this right now. Yeah. So think about it. In this operator here, can you actually test this? You cannot, right? And unfortunately, or maybe fortunately, but when you go to Airflow providers, you have companies that create code and attach it to Airflow, right? And when you go to their documentation, you will see that the way they suggest you use their tool is not very modular at all, to be honest. This is the way that they want you to use it, right? You call the operator, and then you run the query right here from orchestration. So there is no space for you to test your code. How can we solve this? Decoupling, right? You have this clear concept of orchestration and the concept of computation. So why should you be mixing the two things and then you run into problems like this? Testing. How do you actually test your code if you cannot run it locally, for instance, before you even do a commit? To solve that, we have to break things apart. So let's create here a new file. Let's call it decoupled. How am I in time?
You have like 20 minutes.
All right.
Something.
So we have decoupled. Right. Now let me get my assistant to show me code here. Oh, okay. I just quit by accident. 1 second. Oh no, wait a second. This one is... right there. All right. So a little bit of silence, time to meditate, think about your questions. And now let's go to the decoupled part of things. Because this seems to be a little bit boring to people, I'm just going to skip some parts and go directly to the more interesting part, right? So let's talk about downsampling. Downsampling is a very expensive kind of computation that we use to reduce our training sets for models. Because you can imagine that fraud happens very rarely. But when it happens, it has a huge impact. So you actually want to have datasets that capture your fraud, but if you just give it the data that you have, it's not going to, the model won't see it. So you actually have to take out some of the good customers from your training data and keep all of your fraudsters. Do you get the idea? So reduce the data, but don't throw away any of the fraudsters. You want to see all of them there. This computation is called undersampling or downsampling. It's expensive. Here is the orchestration side of things. So you can see that it's a simple Python operator, and I have a Python callable. It's a function. The first one runs with Spark. The second one runs with Pandas, right? So let's look now into the actual function. And this function is the kind of thing that you can actually test. So let's open computation. Let's come here to source, downsampling. Right, what is it? It's a function that takes a path to your dataset somewhere, the name of a column, how many rows you want in your output data, and random seed if you want to provide any. You have some operations in the middle. This is Spark code, and you have the same thing happening down here with Pandas code. Now this can be tested, right? How would you go about testing this? Well, you can use PyTest, for instance. If you code with Python, that's the thing that you choose to use. I did not develop any tests for this one, so let's go for the simple one. Get user mean transferred value, right? So you only take connection params, start date, and end date. You run a query, and from that query, you do some sort of aggregation on chunks of data, because we know that pandas cannot handle the big data sets that we have. So we have to break into chunks and run the computation in the chunks. In the end, we create a little aggregated dataset, and we write this to disk. What about the test? Oh, Yeah, I actually did write the downsampling tests. Anyways. So, get user mean value right there. We have now the test that we can run with PyTest. I have here some fixtures that I can use for my authentication with the browser, right? As you have seen, whenever you run this, your browser is going to go to Snowflake, do authentication, come back and authorize your query. All of these here, of course, are in my environment so that I can't share this kind of information, right? But the idea is that you get the parameters. So right here, the start date, end date for the query. We have the user ID, and I have pre-computed these values, right? I know that this is the value that should be returned. So this, in this case, is the average invoice value for a given day. In this case, between the 1st and the 2nd of July. Should we try to run this? What good is test if they can run? Right, so, Okay, that's good news. Right, I actually have to go into the pipeline, computation, tests, decoupled functions. What's up with it? Test decoupled functions. Pipeline, computation, test, decoupled functions. Get user mean transfer value. Test, get user mean. All right, anybody has suggestions? Now I'm baffled. All right. Okay. I know what's up. I am in the incorrect directory. So let's give it a try again. When the environment is active, yes. All right, so the authentication is happening here in my lower screen. And let me see if the query is running. Yes, the first one ran successfully, as you can see. Now the second one is authenticating. And the two tests passed. So you can actually test now your code without having to submit things to your actual production pipelines, right? So Airflow. This is very useful because sometimes you cannot have access to all the setup that you have in production, but you can mock it, right? So that's the whole idea of having local tests. And right now we're working actually in mocking calls to Snowflake. So we don't want to have our tests actually going to the database and making it busy, right, with dummy requests. So what we're going to do is that we're actually doing mocking it so that the calls go to this local database and just pretend that it's actually a Snowflake call. Did I answer your question, sir? He doesn't even remember that he asked the question. He's pondering the meaning of life right now. Did I answer the question? Yes. Did you get a test? Does it work? Should we look into the code actually? Because right, we didn't see what's happening. So let's go back here. We can look into the code. I'm not an engineer, but I pretend to be. So what do we have to look here? We have to look into the import, right? So this is the import that we're doing. It comes from pipeline computation source, decoupled functions, and then the function that we're actually testing. If we go to the code of it, again, this is going to be inside computation source, decoupled functions, and this is the function. What is it doing? It has a query. It is going to use pandas to read or to execute this query against a connection. What is this connection? Snowflake, right? So you have a Snowflake connection that you pass as a parameter. So right here, connection, actually not even the connection itself, the parameters. And then we have this auxiliary function that we create here, which you can see it's very simple, right? It's just Snowflake from the Python package and connect. You give it the parameters, and now it goes to Snowflake and runs. Gives you back the chunks. You operate on top of the chunks. Here we're grouping by user ID, getting the invoice value and the transfer count, because afterwards we want to calculate the average value in this line right here for each user. The data is already grouped beforehand. And afterwards we write as a Parquet data type here to this data folder. So you can see user mean transfer value is right here, partitioned by date. So we actually have it run twice. We have 2 days here. Does that make sense? I'll consider silence okay. All right. So from here, we already have the big lesson that we learned, and we're refactoring our pipelines. It is that you should not use tutorials as they come, right? You should always be critical of how the information is given to you. You should take a step back and say, hey, do I really want to use it this way? Because Snowflake will tell you, hey, just use my Snowflake operator. It's beautiful. Don't mind vendor locking, right? Don't mind these things. I'll just hike the prices next month and then, well, we'll talk about it. Whoa, you have to refactor all your code now because your whole code base depends on the Snowflake operator. Too bad, so sad, right? So we are actually trying to decouple the best we can from this kind of vendor locking. There are some vendors that are more difficult, right? For instance, AWS, but we're trying our best. All right, so I want to talk a little bit about Spark. I don't know if that interests you. I hope it does, but let's see the time.
Some time, like
Yep.
10 minutes, yeah, I guess.
All right, so let's get to Spark. Okay, right here, decoupled. Let's go to Airflow and see what's happening here. Right, now we have the coupled DAG example, and it has run. It ran only the first one, which is the one that we have just seen, right? Is the pandas get mean user transfer value. Now, what about the next computations? The next one is actually with Spark, and I'm not sure why it's not running. No problem. I don't mind losing the information, so I'm going to delete here. And let's try to recreate it. Let me see what's happening in Airflow. Okay, it is still running. Right, so the DAG is created. We're going to ask it to run. The first one is the one that we have already seen. So as I mentioned, it goes to authenticate to a Snowflake with the browser using my personal credentials. It's going to run for a couple of seconds, and then the second one is going to start. Yes, right, this is the one that we care about. Now it's using Spark. If we come here to the terminal, you're going to see that it's creating a Spark session, right? These here are all the dependencies of Spark. So are you going to do this in your production airflow. No, you're not. You're going to submit this to a cluster, right? But for the sake of example, I'm running in the same machine. Ideally, what you're going to have is you have a cluster and you can use the Spark operator, or you can use something like EMR operator to submit your job to a cluster. So it's going to run. If we go back to the UI, we can see that it is still running. This one should take a couple of minutes. So while we wait for it, let's talk a little bit about Spark, right? What are the two main points of failure or problems with Spark? Can anybody tell me? There are two headaches, two things that if you get right, you won't have to worry too much about the hard documentation and all the different parts that you have to, the moving parts. What is Spark for? I heard the word distributed computing, right? What is that? That's parallelism. We want to parallelize computation, right? So if you want to make things run parallel, you have this concept of a map reduce. And Spark, the only thing that it does is brings the map reduce to the memory. So now if you have a bunch of memory, you can just keep your data in your memory and map computations to your data. That's beautiful, right? But it comes with a heavy cost, and you'll see very quickly that Spark is not magic, right? If you run on small data, it will never run out of memory. But if you have large amounts of data, you will have out-of-memory problems all the time, every time. So how do you avoid them? You avoid them with parallelism, right? Increasing the different amount of executors that execute at the same time. So if you look at this log right here, let me give a description first. This is a summary of your task, right? And you have the duration, garbage collection time, spill to memory, spill to disk, output size that is written, and the shuffle read size. So this is to give you an idea of size of your task, right? Each task is mapping a computation to a piece of data. What's the problem with this? Is this a good execution? Regardless of what's computing, would you like your process to take 1.6 hours? One task. Number 11. Out of 256. Would you like that to happen in your pipeline? Of course not, right? This is terrible. You're not using enough smaller tasks. So what you can see from this log already is that you need to increase your shuffle partitions and how many tasks you have running at once. It's much better for you to have smaller tasks that can finish quicker and more of them than having something like this, that you're having most of the time idle cores, right? Your CPUs are just idle waiting. That's a very good question, right? They shouldn't be synchronized, but because we did such a terrible job, this was on purpose, right? Let's be nice. Since we did this write operation at the end of this, and we wrote it to one partition only, so I did a coalesce, right? You have all these different executors, you force all of them to write to the same file. So now you have an I/O operation that is having deadlocks between the, not deadlocks, but concurrency between the executors. So you force all of them to finish at the same time, right? This is terrible. This is a very, very good comment, actually. Do you guys know Parquet file type, or are you still using CSV? Jesus Christ, do not do that, right? Let's kill CSV. CSV is nice if you have 1,000 rows, 10,000, 100,000. More than that, please drop it. It's not nice. Parquet is much better. You can have a whole talk about Parquet. The basic benefits that you get is you can have metadata associated to columns. You can do filtering before loading data to memory. So, back here, what would be a better scenario? This scenario. What do you think of this scenario? Now we have different percentiles, right? We have this small task running in less than a second, and the biggest task running 16 seconds. Is that good? Is that something that you want? Remember, if this is running in a cluster, you're having to send data across the cluster, network operations. So you have network operation to take 0.2 seconds for computation. That's garbage. That's terrible, right? You shouldn't run in a cluster. If that's the kind of results that you're getting, you should just buy a bigger machine and run everything in one machine with pandas. So this is also a sign of a terribly distributed operation. You have small tasks, too many small tasks. This could be perhaps just, we have here 80 executors. Instead of 80, you could have just 10, 5. You would have much, much better performance because most of the time is actually spent in network I/O, not in computation, right? Which is what you're paying for. You're paying for cores. That's the most expensive thing, right? So that's what you want to avoid.
Well, you also pay for networking, and especially if you're using AWS and you have your cluster distributed across different availability zones, then you pay twice on the way out and then also on the receiving end.
Fair point. Yes. So don't do that. So what is the halfway between, right? Something that you look at and you say, all right, this task is good enough for us not to have to optimize the shuffle partitions and the parallelism anymore, right? You have some tasks that run very, very fast. It's somewhat not even justifiable to have the network overhead, but then you have tasks that are running in around 5 minutes. So you see that 75% of your tasks take at least 50 seconds. That's good. That's something that you can accept, right? 50 seconds, 1 minute, 2 minutes is your target when you're talking about computation in a cluster. Depending on the task, right? Some tasks you can wait a little bit longer, but ideally you want to stay in this range of a couple of minutes, 4 or 5 maximum. More than that, you can just know that you could have more executors running at the same time and get things ready faster. So, what is the takeaway from the first point? Play with your two configurations that you have, shuffle partition and parallelism, right? These two are your best friends. Always give more and then optimize to less than trying to give less, running out of memory and never knowing what's happening with your job. Are we out of time? Yep. All right, so just to finish up, if we come back here, you can see that the Spark job actually ran, and oh, look at this, perfect. The Pandas job was never even able to run. It ran out of memory, right? Because you have bigger datasets, and it cannot run. While the Spark job took 2 minutes to run. This one, the Pandas took 4 to fail. So how much data is big data? Bigger than your memory, right? Should you use Spark? No, don't use Spark if you don't have to. If you can have more memory, use the memory and use pandas. It's much easier, much faster. But if you do have to go for distributed tools, Spark is a very good option. Just one final thing. As you can see, I am a data scientist. I'm not an engineer, but we are looking for engineers. So I'm going to jump ahead of these slides and come down right here. ThinkCrime, machine learning and data engineering. We're creating this team inside of ThinkCrime to take care of our data pipelines, not only offline, but also online, which are the most important ones, right? We want to have risk assessments that enable instant transactions, not in 20 seconds, but in 1 second. So if you are an engineer looking for a new challenge, please come talk to me. 3 pillars are enable data scientists to do experiments. Please let me play with machine learning. I don't want to be doing the pipelines. Second one is to build pipelines that scale and that are fast, and to improve governance, right? Because we do have to handle regulators, auditors. We have to have transparency even for ourselves. So 3 pillars, come talk to me. This is my email and LinkedIn. Thank you very much.
Thank you, Otto. This was a great one. So before we go on a short break, does anyone have any questions? Let's start from over there.
So that's a very good question, actually. In our use case, we only use supervised models. So humans are teaching the models what is right and what's wrong. You do see many different cases where people use deep learning and unsupervised machine learning. It's not our case because we have to be able to explain the decision, and we actually have to be able to explain what feature contributed to a positive score or a negative score, be it fraud, scam, or anything like that. So we do have these tools for our operationals to keep check on the models. So when a model make a decision, he sees why the decision was made, what was the model version, and he has direct contact with us to go and get feedback, change, replace the model. So the question is about vendor locking, how
Yeah,
much we could save by breaking these locks, right? This is a very good question because we are not only inside FinCrime using Snowflake, and we do have the cost centers, right? So we are one of the biggest users, especially in fraud. But to be honest, I'm not sure how much I can share about this information. I can just tell you that it's a lot, right? If instead of using Snowflake, we use, for instance, EMR, we can reduce the cost by a lot, folds, right? Multipliers.
thank you. And here was another one as well. Otto, if you can as well.
I'll repeat the question, yes.
Thanks.
The human annotates decisions of models if they're right or wrong, and we use that to loop back and feedback into model training. So the better labels we have, the better models we have. So this is discrimination, you mean in the sense?
Positives.
Yeah. So we have analysis on top of model performance, right? And also on top of our operationals performance. So we do see every now and then that there is mistake in labeling. So we have to go back to it, change the training data. So we update the labels, right? We call these batch operations that happen every now and then. But I think that the biggest point here is to strive for excellence in our operationals, right? So we try to give them enough time and training and constant training, feedback, time to talk to other operationals too, good leadership so that they can make the least amount of mistakes that is possible. But there is still always a little bit of mistake included. This is a benefit that we have of having so much data, is that these mistakes, if we have enough good labels, they are just noise into the model training. So it's not that they are going to teach incorrectly the model, they just make it harder for the model to learn the correct signal. So they impair the learning, but they don't teach wrong things.
Thank you. Any more questions?
I
All
think
good.
the machine learning part was more interesting, right? Maybe should have me about machine learning.
Maybe definitely next time. So this let's make it the last one, please.
Yeah. So that's a very good question. It is, how do you validate that the decisions of operationals are truly correct, right? When you call something fraud, that it's actually fraud. In an ideal world, we would have the police working closely with us in order to take criminals to justice and then make a decision. A judge makes a decision, right? Because we are not judging anything. We're talking about people using our platform. So whenever we call something fraud. We're saying that this has either caused loss to the company, and we're not willing to have this kind of behavior in the platform, right? Or other cases, for instance, of regulators, AML. We have regulators that ask to see cases, right? They come and say, hey, let me see your data, let me see what was your model prediction. So we are trying to abide by rules, law, and regulators while impacting our customers the least possible. We want everybody to use the platform as long as they're using it correctly. How we judge correctly is why we have operationals, right? They are well trained, they interact a lot with the police. Like I said, ideally we would have a trial, but we do have interaction with the police, and that's, you cannot let the perfect be the enemy of good, right? So we are happy with the quality of output that we have had so far.
Thank you, Otto. It was a great talk. Please, may I ask for a round of applause for Otto once again.
Thank you very much.
And from
engineers, come talk to me. I'm serious.
And then from DevClub side, a gesture of appreciation. Here, I branded socks for you.
Thank you very much.
Yeah. Thank you so much. And ladies and gentlemen, we will have a 20-minute break. Have some pizzas. I believe they got delivered just a bit ago, and then have some drinks, and then see you in 20 minutes. Thanks.
Terus? Sì, sono dalle
So, ladies and gentlemen, we're starting with Andrei's talk in 1 minute. So, please get ready. All right, so I would like to invite on stage Andrei, who is a long-time speaker at DEVCLUB, countless times, 10 times, 20, 10 times.
I don't know. I don't know.
Way too many, way too many. So please, let's give him a warm welcome.
Yeah. Thank you. Yeah, we can begin. Hello, everybody. Welcome. I will talk a totally different topic. It's not absolutely similar to the previous topic. Absolutely different. So I will talk about flaky tests, or how to deal with flaky or unstable tests. Introduction. When you write you or your company create some software, writes some software, you want to be sure that it works, right? You want to be sure that your software works. And works now and will work in future also after any kinds of changes, refactorings, new features, and so on and so on. And the only working way to be sure that your software works is automated tests. You write code, you write tests, you run tests regularly, and you can be sure that your software works. At least this is how we work at Codeborne. We do use pair programming, we do use extreme programming, we write code, we write tests, and we are always sure that everything is working as we expect. Let me show what is automated tests. Let me just run some automated tests that runs against some randomly picked site in internet. Yeah, this is how automated test looks like. It opens a web browser, it starts clicking some buttons, start typing some values, some text inside, and so on and so on, and verifies that there is a correct page on the page, correct text on the page, and so on and so on. So these are automated tests. These are basically robots who help us to verify that software works. There actually are different kinds of automated tests, like unit tests, integration tests, UI tests, end-to-end tests, and so on and so on. But all of them have one common problem. Actually, they have many of problems. But the biggest problem is that these tests are often flaky. What it means? Flaky test is a test that fails, but not always, but time to time, from time to time. This is a test that fails sometimes without any code changes. This is a problem. So it often looks like this is your build history, for example, and it always can happen that some build is green, some build is green, but oops, next build is red. Some tests have failed without any changes. This is a problem. And when the test fails, why this is a problem? When the test fails, in theory, it should mean that you have found a bug. You have some bug to fix. But in case of flaky tests, you never know if this is a bug or the functionality is okay, and this is just a flaky test. Just random failure. This is a problem.
A bug in a test.
Yeah, it may be a bug in production code. It may be a bug in a test. We will see some cases. Yeah, today. This is a picture that I always often see. For example, QA engineer, like tester, comes to work and sees that last build has failed, and he has, for example, 30 tests failed. He says, okay, I need to investigate it. Let's investigate it. But a few seconds later, he decides, well, you will probably know what bad word is hidden here. Disgusting word is written here. Yeah, you know. He decides, okay, let's rerun the test. Probably next time it will become green. Ooh, let's hope so. Yeah, so this is how often typical day of QA engineer looks like. Like he runs automated test, or not he, but Jenkins, some GitHub Actions, or some like robot CI server runs automated test, and it takes probably, of course it varies from company to company, it probably takes like 20 minutes, let's say. Then some of them fail. He decides to rerun the test. It takes again about 20 minutes probably. And still some tests have failed. Probably some other tests have failed. And then he needs to investigate why it failed. Analyze failures, yeah. And it might take much more, probably half of a day, probably the whole day. And this is a huge problem for me. This means that all the release process is forced to wait until you clarify, was it a bug or was it just a flaky test? It takes a lot of time. It makes our release process much slower. This is, for me, this is a big problem. That's why I like to say that our industry is in danger, actually. Yeah, it should be automated testing, but it's not really automated. It needs a lot of manual works from our side. I am seeing that this is important topic that we need to discuss, and we need to share our knowledge. We need to share our experience and like invent some ways to fight with flaky tests. So today plan is, I will show my favorite collection of some flaky tests from real projects, from real life. They are kind of interesting. They are really tricky cases that I had been investigating for days, for nights, for weeks, sometimes even for years. We will see, like 5 examples like this. And in the end, we will try like to analyze a little bit what are typical reasons of flaky tests and how to fight them. So let's start from my collection. For the beginning, let's see a very primitive example of flaky test. This is a very like classical example of Selenium test or UI test for web application. In this case, for Google search. The question is, what line in this test might be flaky, might fail sometimes? We have a typical Selenium test. The first line like opens a WebDriver and opens a Google page in it, right? Next line finds this input where we need to type in the query, and third line clicks like submit button, like yeah, search, I want to search, and last line I verify that there is like expected number of search results. Which line of these lines might be flaky? Last one. Yeah, that's the right answer. Actually, any of this line. Let's see why. The first line might fail sometimes, not every time, but sometimes. For example, because of slow internet, or for example, because some of our microservices is down. In case of Google, it's like never down. But in case of our software, our enterprise applications, it often happens that some service is not deployed or is down or something else. Or some external dependency is not working today, or Amazon is pretty slow today, something like that. This line can also fail. For example, if in case if this element is not rendered yet, if it's being rendered a little bit slowly today, something like that. This line, this is interesting, why this line might fail. Last time when I tried, it failed with this exception. hard to understand. But in reality, it says that this element that we tried to click is not clickable. And it's not clickable because some other element would receive the click. No, basically, it means that our input is our button, submit button, is covered by some other element. Let me show the video how it happens in reality. Don't read the text. Currently, the text are in Russian. Sorry, but this is a video from running tests. So we are the first line worked. We opened it a browser. We opened Google. Second line worked. We typed in the keyword. What's next? And now we are trying to find the submit button, but we cannot find it. But where is this? Where is this submit button? Where is button? Oh, here it is. It's hidden behind this preview pop-up or whatever is this preview thing. This button is hidden behind this preview thing. And this test doesn't fail anytime. It fails sometimes because sometimes this preview is not rendered immediately, but with some delay. And sometimes test can click this button before this pop-up appears. Sometimes not. Yeah, it's called Flaky. Yeah, sometimes it works, sometimes it fails. Okay, let's continue. And this line also may fail, probably because not all elements are already rendered. Probably they are rendering a little bit slowly. Probably the list is being loaded a little bit slowly. Again, not in case of Google. Google also works fast, but in case of our applications, often happens. So to a little bit summarize the introduction, the reason of most flaky tests in the world are, from my experience, the following. The reason of flakiness are mostly asynchronous requests, speed of requests. Sometimes requests can be slow, can be faster. Sometimes the responses may come in different order. Sometimes browser a little bit slower, or JavaScript executes a little bit slower than usual, and so on. So these are the most common reasons of flakiness. And I have a good news. I'm happy to say that there is a cure for these problems called Selenite. Selenite is a library for writing automated tests, and it solves most of these problems. Selenite is like a library on top of Selenium. If you are writing tests in Java, yeah, it helps. If you rewrite the previous Selenium test to Selenite, it looks a little bit more like concise or readable. It's a little bit easier to read such a test, but this only the first advantage, but really bigger advantage is that this test becomes much more stable. Why? Because Selenite contains so-called smart weightings inside. Any of these lines actually does assert, it does verify that this element is visible, or this element like disappears, is not visible, and so on and so on. It can check like text of element, color of elements, size of collection of elements, and so on and so on. And what is the biggest point is that any of these checks is smart. If it's not visible yet, then Selenite will wait a little bit. We call it smart weightings. It solves most of problems with async requests and so on and so on. Slow JavaScript and so on. Now, once again, any of these methods will wait up to 4 seconds if needed, only if needed. And of course, this timeout is configurable. So yeah, it's not a problem. And additionally, in case of test failure, Selenite also takes automatically a screenshot and saves the source of this web page. So it's easier to investigate why the test failed, what exactly there happened. This was like a brief overview of most flaky problems that Selenite can solve. But the most interesting part is the other 10%. These are really tricky flaky tests that are really interesting to investigate for me. And my other examples are like from this non-trivial part of Flaky tests, which are really tricky. I guess I will have like 5 examples. First 2 are more technical, others are more entertaining with video, with animations, clicking buttons, and so on. So the first one is like more technical, but it's just an example of Flaky test. Once upon a time, we had the test that was actually all the time was green, but started failing at the place which verified that some card which was displayed somewhere in internet punk should have expected expiration time, but it started failing. Yeah, in autumn, when the autumn began, this test started failing, started to fall. This test looked like this, like some card should have text like expiration date December 19. But starting from some day, this test started failing, and in reality, in browser, there was visible other date. Not this date, but this date, for some reason. It was like magic. Yeah. Why it started failing? Because we didn't change any code. When we looked into the code, we found a little difference. In production code, we found that this expiration time of the card was displayed using this code. But in test, which verified the expiration time, the expiration date, this test was written using this code. Can you catch the difference? Exactly, right, yeah. And yeah, this expression gives this value, and this expression gives this value. Yeah, which one is correct? Which one is better? Which one would you pick up? Yeah, this was an interesting challenge. Actually, it's quite, yeah.
Was this JavaScript code?
No, it was Java code.
Okay, but have you then looked into the docs, like what is the difference and why is like off by an entire like year?
Yeah, sure. After this test started failing, we started reading docs, yeah, investigating what exactly it means, and it appeared that small or lower letter means year, and upper letter means a week-based year. What the fuck? What it should mean? Yeah, you would say. Let's see. Like lower letter means actually the normal year, as we will understand. Like, yeah, this is 19. It's clear. Yeah, but the uppercase letter means that this is a year calculated from a week of this day, or more exactly, this day was. Sorry, I did, refactor the slide for this one. Yeah, how these days they looked like inside of a week. This day it was actually a Tuesday. Yeah, the card expiration day was actually on Tuesday, and if we look in which week it's located in this week. And if you ask to which year this week belongs, actually, there is a correct answer. This week belongs to next year, because most of this week is in this year. So the uppercase means that actually for this day, yeah, the week-based year is actually 20. Yeah, this is crazy. Who invented it? But yeah, probably it is important for some accountants or something like that, like yearly reports or something. Yeah, you can read more details. So summarizing, summarizing, this is essentially a bug in the test code. Simple, but it worked most of the time. It failed only few days in a year, up to 3 days, no more. And it failed even not every year, but only in some years. But it was quite easy because during these 3 days, it was easy to reproduce the failure. It failed every time. It gives you like up to 3 days to debug the issue and understand what happens. The next issues are much more complicated because you could not even debug them because they do not fail next time. So when we are composing a list of typical issues, typical problems, yet another one is like bugs in test. This is trivial, but like tricky bugs which work correctly most of the time. Let's see the next example, Java time. Yeah, we had some test. Again, UI test for internet bank, which opened some payment or created some payment, like submitted some amount, submitted some account number, clicked submit, and it very, very rarely, probably once in 100 times, it failed, saying that status of the payment is wrong. It's not like completed payment, but it's like waiting payment for some reason. Was not absolutely clear why the status is wrong. When we tried to debug this test or run on my machine, it always worked, always. We could not reproduce the failure of this test. When we started like investigating the code, we found the place. The problem was that time of this payment, like payment time, was not in past, but was in future. And it was strange because the test actually created this payment like 1 second ago. Test creates a payment, it should be in past, but oops, it's in the future. How it's possible? It's strange. Yeah, we started investigating all the code, and yeah, check was basically like this. I said that sometimes failed was like this. The time of this payment should be like in past, but it was in future sometimes, very rarely. It was like magic. Yeah. And this was the only place how we actually initiated payment time. New date, no other options. Like it was not some other if which read this time from us, some other JSON or something like that. No, only new date. Yeah, it's still Java. Yeah. Yeah, it seemed that it's not absolutely possible. How it would be possible to investigate or understand what exactly happened. And the last hope was just to read carefully all the application logs. And we started reading application logs during test run. And at some moment we discovered one strange thing in logs. This is like a request log, which for every incoming HTTP request logs URL, parameters, response, and so on. And we detected one strange thing in the request log. This log says that this request was like handled so many milliseconds, which is like impossible. It should be always positive number, like 10 milliseconds, 1000 milliseconds, but not minus 3000. It's not possible. So it was a signal that probably we should investigate. But what? how it possible? I don't know. Yeah, we started trying different experiments. They didn't help. But finally, what we did, we created a simple bash script, which actually like run in cron every second and just logged current time into a separate file. And what we found magic here. Yeah, this is a result of this like bash script which runs every second and logs current time. And yeah, you see a mystery here. Something happened here. So the problem was not with Java, was not with like tests, but it's like system time, Linux system time. Yeah. No, like Ubuntu. I guess it was Ubuntu. No. Interesting. No, it was just a dedicated continuous integration server like Jenkins on a separate machine. Yeah, exactly. Yeah, the mystery was solved like this. We found that this Jenkins server had actually 2 services for time synchronization. The first one is called NTP, and another one is called system D, like this one. As much as I understand, in some older Ubuntu versions, like probably this one was default, I guess, and starting from like next Ubuntu version, this one was default. And administrators upgraded Ubuntu so that both services left. Both services were working all the time, and the first one was this NTP, and it worked like regularly, and another one was this service, and it also worked regularly. And the problem is that they connected to different servers. You know, the services connect always to some server to fetch current time. And they connected to different servers and fetch at different times with quite a huge difference, 3 seconds. And sometimes bothered each other. It was absolutely, it would be impossible to find. We were just lucky, and we really wanted to solve this issue. And just one takeaway, how to measure times in Java. We typically, if we want to measure how many seconds or milliseconds some code took, we typically write code like this, like start, end, and in the end write like end minus start. And because of this issue, I got to know that actually it's not really a correct way to measure times. Sorry? It's correct, it works in most cases, but really good way how to measure times is actually using nanotime. This is a new method which was added in Java 6 probably, like new method for me. It does almost the same, but with one huge difference. It returns not milliseconds but nanoseconds, but it's not important. What is really important is that current time millis returns actual date. You know how many milliseconds is spent from beginning of our era and so on, but it returns real date. And in case if some system services synchronize time differently, it returns different times, and it might return even negative times and so on. But nano time it doesn't suffer from this problem. It's not connected to any real time. It's just some abstract counter, which is guaranteed to increase every nanosecond, plus 1. And it can start with absolutely any random value, probably even negative value. But it's not connected to real time. So, always is recommended to use nanotime for measuring times. So
it's not really a time, but just a counter.
Yeah, it's just a counter. No, in some sense, it's not connected to real time. In some sense, it's time from JVM start, something like that. So the summary is that it's recommended to use nanotime, but the funny moment that exactly the fact that we used bad way to measure time, this fact helped us to discover the issue, actually. Let's stop with technical stuff and let's see some more entertaining stuff with pictures and videos. Another example of Flaky test, which was a little bit hard to investigate in the beginning. I call it nbop. Once upon a time, many years ago, we did an internet bank for in kiosk mode, in public places with big screens. It was called kiosk, and we wanted to write. We had actually automated test we tried to log in to internet bank. This automated test, which it tried to enter username Bob. This is username here. It tried to internet username Bob in this place. How it did? Test tried to find letter B, click it, then find letter O, click it, and again find letter B and click it. And most of the times this test worked, everything was okay, but sometimes, very rarely, this test failed, like because of wrong username. And when the test failed, we saw on the screenshot that actually we had here not Bob username, but nbob. What? Like, how it's possible? We started looking, do we really have some nbob username in some of our production code or tests? No, we did not find any nbob string anywhere in project. We looked in all kinds of Excel files, databases, wherever we didn't find nbob in no places. How it's possible that nbob like is visible here? Is it a bug in test or in production code, or what happened here? Like some asynchronous request, or what happened exactly? When started looking into the code, tried to debug this code, and like experimentally we found that, yeah, we applied binary search, so we tried to like comment half of lines and run test again and again. And experimentally, we found out that the letter N appears there after this line. So when the test did like body click, then letter N appeared, and then the next line like added Bob here. So how exactly why the N letter appeared? And now, if you look on this to this picture, you probably might guess. Exactly, yeah. N is exactly in the middle of the screen, and body clicks in the middle of the screen. That's why we had nbob. Another, yeah. Yeah, it's a good question. Let's see it next slide. But another question is why this test did not fail every time. This is an interesting question. If this test would fail every time, it would be easy to debug it. It would be easy to find out what happens, but it failed like not every time. Let's see answers. Yeah, first of all, why the click was needed? It was hard to find out why. And the only theory was that probably someone clicked body to like move focus out of some previous input. It was like important to move focus out of element, but Selenium doesn't have such a method. JavaScript also doesn't have such a method like move focus out, like blurs. Okay, probably JavaScript has. Yeah, and somebody like just found this way to move focus out of element, and he did not think that this click might occasionally click something else. Yeah. So moral here is that yeah, don't insert anything into body. Don't click just in case something. Yeah. But answer for the second question, why it didn't fail anytime? This test actually dependent on size of the browser window. Sometimes browser window could be smaller or bigger. It even depended on like your screen. Because that time by default like browser was opened like maximized on the whole screen. On some displays it might fail, on some other displays it did not fail. And if you run test in headless mode, in like Jenkins, there is, as much as I know, size is not like defined, is not specified. It might be quite random. That's why I took another takeaway that probably it's a bad practice to start browser window maximized, as many do actually. And instead of that, it's a good idea to fix browser size and put probably the minimal resolution that your application supports. Yeah. And another, from some Selenite version, we even like deprecated and even removed the setting. Yeah, from version 5, I guess. Exactly because of this Flaky test. And another takeaway is don't rush. I guess that body click was added like just trying to overcome some problems, just trying to like move focus without deeply thinking how to achieve the same goal like properly. And this is a little bit theory. Yeah. Do you really know how click works in Selenium? It's interesting, and actually it's the reason of many Flaky tests. Click in Selenium works like a little bit strangely. It works in 2 steps, and this is a problem. It does really 2 steps. When you call like some element click, Selenium first of all finds the coordinates of this element, of center point of this element, and second step, it clicks on these coordinates. Yeah. What might go wrong? Yeah, what can possibly go wrong? Yeah, if something happens in between these 2 steps, for example, if between these 2 steps the element was moved, was resized, or some other element was resized exactly at this moment, and so on. Yeah, and what might happen, Selenium clicks at this point, but at this moment element is not at this place anymore. So yeah, it often happens. Let me show one small experiment. I wrote many of experiments. For example, this one. I created a dedicated page which has a moving element, and test just calls click in a loop. And this page tracks was the click exactly at this point or it was missing. Yeah, and we saw that it was missing quite a lot. Another experiment was we are trying to click element which is resizing all the time. Yeah. You see that quite often it misses. It clicks not exactly the right point. Yeah. Right. Right. In most cases, it's not a problem if you click not exactly the center, but a little bit side. It's not a problem in most cases, but sometimes it may even click outside of the element. Yeah. Just it's even harder to reproduce this case, but it's possible. Yeah. We will see. How to overcome this problem with click? It may be done differently. In some projects, we actually disable animations during test run. I know that many don't like this approach, but yeah, it's actually a really stable approach. This is just one example how we disabled animations in one project which used jQuery, so it's quite new project. Yeah, something like that. We had to Google and find out some CSS styles and JavaScript snippets. Yeah, this magic code disables animations in jQuery. Probably it's also possible to find out similar code for any other frameworks like Vue, whatever, Svelte, and so on to disable animations. This is one option. Yeah, but it has one hard thing. Why it's not always simple to apply this approach, because it means that you need to do one disgusting thing. You need to do one really hard thing. Yeah, you need to talk to developers and ask to add such a code in production application. Right? For many, it's a big obstacle for some reason, but yeah, I believe it should not be obstacle. Another example, check and click. Yeah, let me show another video. Once upon a time, we had a test that needed to do two things. You will see that currently will be loaded some table of elements, and the test want to check one checkbox and click the button. Let's see. The test checks this checkbox and clicks the button. And I especially added some artificial code, some highlighting there. If the clicks the button changes from blue to green. You see, in the beginning, button is blue, and if test successfully clicks element, it becomes green. Yeah, this is a successful test. In most cases, it works like this way, and everything is fine. But sometimes this test failed and button did not really become green. Very rarely again. Let's say this is the same running test a little bit slower. Why exactly it could not fail? Yeah, we can see that what happens here, that we have silver elements loading quickly and REMI elements loading slowly. For some reason, someday, it's not a general rule, but at some days it happens so that REMI was slow. But for some reason, REMI is more important than silver, and REMI lines should be like in the beginning of the table. So what happened, test was trying to check some silver checkbox, but silver was moving at this moment. And then test tried to click this button, and button also was moving because of loading REMI. Yeah. In most cases it works. In most cases it can click the button. And so to make this video and reproduce the failure, I had to like rerun the same test in loop many times. Once works, other case works, third time works, fourth time. Yep, it didn't click the button. You see, click button remains blue. Click missed the button. This is exactly the case how click works. And now this is an interesting question: how to fix it? How to fix it? One option, most commonly used option, is to just put a sleep. Just put a sleep, to which like guarantees that the table is fully loaded, and then check and click. You probably all know why it's a bad idea, because it makes our test much more slower. This test will always wait 3 seconds, even if actual table loads very, very quickly. And another problem is that sometimes 3 seconds is not enough. Sometimes table is still loaded a little bit longer, and then your test will still fail. Another option was to disable animations, like I showed it before, but yeah, not everybody thinks that this is a good idea. Some people say that this is a bad idea because it probably hides some bugs like caused by animation. Okay, good point. Yeah, in this case, it would not help even. Yeah, good point. Yeah. Yeah, good point. Yeah, absolutely. And I believe that actually the right fix is like this. We need to change both production code and test code. And production code should be, yeah, you probably could see that actually we have a usability issue here, because the button is enabled already immediately in the very beginning, before any data is loaded. I would say that this is a bug, this is a usability issue. But the problem is that this is not a big issue. Like real clients do not suffer from it. They can wait and click. They can click once, oops, miss it, click again, oops, miss it, click again, works. These are users which are faster than computers, yeah. That they are also smart. So this is a usability issue, but like low priority, 0 priority. This is a problem. And I would say that I would fix this issue like this. In production code, I would disable the button in the very beginning, or even probably hide the button. Then load all the data, and only then enable the button. For me, this is a proper behavior of the application. And it would allow me to, in test site, like first wait until this button is enabled, and only then click it. Like easy. It would be really stable test without any problems. Let's see what's next. Yeah, how to fix it. And I tried to make a video of like fix it button, which is like disable it in the beginning. Yeah. Then after loading, it becomes enabled. Then we can check it. Yeah. So it works. So we got a stable test and we fixed usability issue. And that's my goal here, to motivate you to make proper fixes, to talk to developers, to ask to add some locators or disable some buttons at right moments, instead of like putting sleeps in tests. I'm trying to motivate you to like find proper solutions. And the last example is a curse of the grid button. This is an example where we could not find the reason. Absolutely. We tried to add logs, we tried to debug, investigate, to find code. We could not find absolutely any explanation why this test sometimes failed. And only video helped us. Let's see this video. Oops, sorry. This was absolute magic how it happened. Sorry again, the texts are in Russian, don't read them, I will comment. We had the test that tried to click a button. Details are not important here. It tried to fill some fields, click button. Yeah, this is the important part. The test was trying to enter one-time password here, like 0000, and click submit button. Yeah, click submit button. And in most cases, again, that this test worked, but very rarely, sometimes it failed, and it stayed exactly on this page. Like this test should click this button and like get to the next page, but sometimes this test remained on this page without any errors. Just test is waiting on this page for something. Just is waiting. We checked all the Ajax requests, all the logs, all the, like smart waits for timeouts. We could not find anything, any explanation. Why is the test like clicked button, but like didn't click the button and didn't get to the next page. And only video, only when I found the library to save videos from running tests, only using this video I could find the explanation what exactly happens. Let's look again on this important place. Now I run this video like slower, much slower. What happens? Test enters these zeros there, and now tries to click the green button. Did you see it? What happened? Let's run this video again, even more slower. What now happened? Test clicks SMS, enters 40 here, and now looks below. Look below. There is button, but there is a gray progress bar which appears for like 1 millisecond and disappears. This is a problem. And click sometimes get exactly not to the button, but to the gray progress bar. Yeah, look once again. 4 zeros, look at the button. Dish, it's covered by progress bar, you see. And progress bar disappears now. Oops, disappeared. So in most cases, test could click the button, but sometimes it clicked the progress bar. Yeah. Yes, there is a way for browser to know if the page is loaded. Actually, Selenium by default waits for the full loading of page, but this in technical terms it means like event document ready, something like that. But nowadays all the pages works like we using asynchronous background request and so on. So the page is loaded, but it still runs some background request all the time, still refreshing something. In this case, page was loaded quickly, but then something happened. For some reason, browser decided to show progress bar for 1 millisecond. And actually, if we think about this problem, why browser decided to show the progress bar, the real reason is that actually for some reason this HTML page is too white. It's too white. It's too long, and actually there is a lot of important information there on the right of the screen, out of the screen. Actually, this is again usability issue. We should change layout of this page so that all the important information should fit into the page. This was really ugly layout of this table. Yeah. but nobody complained. Like real users could find all the information, but test suffered from it. In some sense, this is a big point for me, that very often when a test fails, it signals about usability issue in the application, which is not so much important from business side for you probably, but yeah, we could fix it. Yeah. Mm-hmm. Mm-hmm. Yeah. Mm-hmm. Mm-hmm. Yeah. Yeah. This is a good question. Usually we run tests on Chrome, or in bigger companies, bigger projects, they do run tests on all browsers. Meaning Chrome, Firefox, something like Edge. Earlier it was Internet Explorer. And as much as I know, most of people do not run tests on Safari, because Safari is ugly in that sense. It does not Apple does not provide WebDriver for Safari for some reason. This is the only browser which does not have good WebDriver. All other browser providers provide browser and WebDriver, acceptable. Yeah. So it's possible to run tests on Safari, but it's hard. It often fails. Yeah. Yeah. Selenium is often used for scraping. Yeah. Yeah. I didn't understand who did update. Selenium, yes, Selenium is open source.
For your own application.
Yeah.
But if you're using the Selenium for scraping,
Yeah.
then yes, somebody can figure out that, hey, guys, you're using Selenium to scrape.
Yeah, exactly.
And go to the hell. And we are trying to do some tricks that when you come with the WebDriver, then we will move stuff around or
Yeah, exactly. Google is especially smart in that sense. A few years ago, I wrote a UI test for Gmail, which tried to log into Gmail and check that inbox has 5 letters, but I cannot run this test anymore because Google always answers, sorry, you cannot log in. You are not allowed to log in with Selenium to Gmail. And I cannot overcome this. I don't know how to do it. Yeah, Google is smart.
Why not use explicit weights of Selenium instead of Selenite? So basically it does the same function, just waits when some element appears and then run remaining tests.
Yeah, the question is why not use Selenium explicit weights? In some actually Selenite methods should have visible and so on. It's exactly the same thing that Selenium expected weights, but it has much more concise syntax and it has many benefits. For example, in case of test failure, it prints out a very readable error message, screenshot, and so on and so on and so on.
Thank you for the presentation. Are there things which we can't test or it's very difficult to test? Using, for example, this tool or any other tool. In principle, testing, are there things which we can't test?
Testing other things that are not testable, you mean?
For example?
Yeah, of course. There is a lot of things that are harder to test. For example, if you have Flash, some site using Flash technology, it's not almost automatable. Some games, for example, some native applications on Windows. It's technically possible to test, but it's much more harder, and these tests will be much more flaky again. I didn't try it yet, but yeah, Canvas. Okay, yeah. Okay, yeah. Then this is the same problem. We cannot like find element by ID or something like that and click it. And the only way is to find elements by coordinates, for example, which is much more flaky. Yeah.
Just shortly, sometimes you should basically simulate human behavior, right? Correctly. So is it always so easy for you? Is it all the basic actions, or sometimes it can be complicated to simulate human behavior, even on such?
Yeah, of course. Yeah, this is a very good question. When I write automated tests, it's often hard to emulate real user behavior. If you mean that user should shift cursor to the right and very quickly to the left and like find some drop down, yeah, it's often hard to simulate. And for my opinion, people often do this mistake that they do all the best to really simulate user behavior. And for me, this is actually the wrong target. This is a wrong goal. The real goal of automated tests is not to emulate like real life tests. Is not. Real goal of automated tests is to automate all the things that are easy to automate. It's hard to explain probably, but yeah, the point is that manual testers are smarter in some aspects and robots are smarter in some aspects. And we need to use humans in these areas where others are smarter, and we need to use robots in these areas where they are smarter. Like simple, yeah. It's not the goal to absolutely replace people. Yeah, it's not possible and it's not reasonable. Yeah, yeah. 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 Right.
There was also a question over there.
Yeah.
Please.
For the Gmail test, did you try disabling the JavaScript, or do you know this thing like the Gmail basic version is there, whereby you can say load basic HTML?
Probably not.
Yeah.
I did not try.
There's one thing called load. When the web page is slow or something, there will be a thing in the down saying load basic HTML in Gmail.
Ah, okay. No, I didn't try it.
Yeah, you can try.
Probably I might try. Yeah. Thank you.
Not only you can teach something, but you also can learn something.
Yeah, of course, absolutely. Yeah, yeah, of course. Actually, I had a lot of other slides also, but yeah, probably it's time to finish it. Yeah.
Yeah, I think we can squeeze in a couple more questions to make it a nice ending. So, if any questions have left, you made it also clear.
Yeah, thank you.
Well, thank you, Andrei. It was a great one, as always.
Yep.
Also, a pair of socks to you.
Yeah, thank you. Yeah.
Thank you so much for joining us. And again, this is it for tonight. Massive thanks to Wise for hosting this one. And we at DevClub are working hard on the next one already. And it is likely to come following month, early August, likely. So stay tuned and make sure you don't miss it. In the meantime, enjoy the summer, have fun, and see you in a month.
Yeah. Да, спасибо. Мне понравилось. У меня на самом деле еще дофига